All right, let's get started. I gave you a warm-up, but I'm not going to do the warm-up. As my agenda says, take the warm-up home. I'll probably post an answer key to the warm-up. All right? It's material from last class. You should know how to do this. I've added some extra problems on the back. They are a mix of concepts of molarity and starch and some such things, or molarity formula and molarity by dilution. All right? So you need to know how, if I mix up, how to do those problems. We're getting into the next topic, which is acids and bases. Let's take some notes. All right. How do acids taste? Sour. All right. Acids taste sour, and how do bases taste? Taste bitter. All right. How do you recognize? Yes. I distributed this package last class. You must have received it last class. You must have picked it up by the door when you walked in. I didn't get to it last class. And I don't think I have extra copies of it. I have run out of copies of this. Okay? I don't know, I made so many more extra copies, but they all seem to disappear. I found it. Well, I found... Well, is this yours? It's not yours. It's Chem 1, it's very similar, but it will not be the same. But it's something to start with, alright? It's not the same as the other one. Okay? Yes, do you need a copy? I don't think I have... S-O-U-R. That's S-O-U. You know how my smart board is. Sometimes when I write. Okay? Well, I found, hey, here are the extra copies. I found one. Okay, I can give Justin one. Thank you. Here. Harry, I found an extra one. Anybody wants? Oh, there are two more hands going up. For you to decide who gets what. Okay. Let's get started. We have limited time. Alright? So, acid states sour. How will you recognize if a liquid is an acid or not? If you dip litmus paper in it, litmus appears red in an acid and it is blue in a base. Alright? What is one other property of acids? If you react metals with acid, what do you think you will get? What gas will you get? Hydrogen, because all acids begin with a H, alright? So you will get hydrogen gas, alright? Bases do not have such a reaction, a common reaction, but bases are slippery to touch, alright? Are slippery to touch, alright? In general, you can say, what do acids begin with? Begin with H. And what do bases end in? Bases end in OH. Now this is a general statement, alright? So let's do some examples of everyday life that are acids. Orange juice contains what acid? Well, the primary acid is what? It does contain ascorbic acid. Citric acid is the primary acid. all right? But it also contains ascorbic acid. Now, what is ascorbic acid? No. What is the general name for ascorbic acid? Vitamin C. All right. What other acids do we use in our everyday life? Yes. In it? I would imagine that it will contain a bunch of things. Orange juice concentrate itself is a mixture of compounds, one of which will be citric acid because that's what lends it sour taste. Any other acid that we use in our everyday life? Milk is slightly acidic. All right. Vinegar, lime juice contains the same citric acid, Thomas. All right. So vinegar is what acid? Acetic acid. What do our muscles produce when we get tired? Lactic acid. All right. So all these are acids that we encounter in our everyday life. Let's talk about bases. Bases are slippery to touch. Soaps. Bleach. All right. Anything else? Huh? Blood. Blood is mildly basic. Blood is mildly basic. Very mildly. All right. It won't be slippery to touch, but it's mildly basic on a pH scale. Yes. That is a proper base, but I'm asking about everyday life substances. Huh? Baking soda. All detergents, cleaning supplies. All right? Yeah. Cleaning supplies, Windex. All these are generally bases. All right? Your drain cleaners, anything is a base. Okay? Acetone is a separate class of compound. All right? Okay, let's distinguish. Now that she has asked Adam and company there, can we be quiet? And this is getting recorded, by the way. I have a lot of evidence. Okay? So let's distinguish an alcohol from a base. We already did this. See, I don't remember which class I did it with. And then kids are like, you never taught us this. I'm like, oh, okay. So alcohols begin with what? Carbon-containing compounds that have OH group are called alcohols. We can drink some of them. We can use them in cooking. But cooking. All right. Carbon-containing compounds. But then bases are inorganic compounds. What are bases? Inorganic. It's generally a metal with a hydroxyl group. Yes or no? They are bases and we can drink them, right? And very mildly, some bases can get used, like bitter gourd contains a base, that's why it's bitter. Okay? So, do you see that? And acetone and all these are a special class of organic compounds. Now, what is a hydronium ion? We talked about acids as those substances that contain a hydrogen ion. Is that right? When you add that substance, you say it's hydrogen plus, all right? But scientists have tried to find evidence of hydrogen plus in solution. They say that, oh, you really cannot find hydrogen plus because it's too small of an entity to exist by itself, all right? There are a lot of theories out there. So people will often refer to a hydroxyl ion, a hydrogen ion as a hydronium ion, all right? Or even a higher complex, but then You shouldn't get confused, all right? They are referring to an acid concentration, a hydrogen ion concentration. Does that make sense? It means one and the same thing, all right? So, what are these substances that are acids? Now, people have realized that things that are sour are acids, and they've been studying this from a very long time. Arrhenius was the first scientist to come up with the definition of an acid. He said acids are substances that contain, produce a hydrogen plus or a hydronium plus ion. All right? A hydrogen or a hydronium. What are bases? Are substances that contain or produce a hydroxyl ion. All right? So that was how Arrhenius started his definition of an acid and a base. But then what happened was it did include a whole different class of compounds which eventually people found are also acids or bases. One such example is ammonia, and ammonia is a base. All right? So if you look at Arrhenius' definition, how could you classify ammonia as a base? Because it doesn't contain a hydroxyl ion. Is that right? So the definition of Bronsted-Lowry's acid remains the same. He said acids are substances that donate a hydrogen plus. All right? And bases are substances that accept a hydrogen plus. So by this definition, if you treat ammonia with water, what do you get? So this becomes the acid now. This becomes the acid, and that becomes the base, because the hydrogen is transferred from water to ammonia, all right? And ammonia will, after accepting a hydrogen, become what? NH4 plus, and then the what is remaining of water? OH minus. Is that right? So now it gets classified as a base. Does that make sense? It's a proton acceptor, whereas an acid is a proton donor according to Bronsted-Lowry. Does that make sense? What? So an acid always have to have a base for an acid-base reaction to take place. Does that make sense? Now, what are conjugate acids and bases? Conjugate acids differ from their base by having one more from their base by having one more hydrogen plus. All right? So the acid will have, the conjugate acid will have one more hydrogen plus. All right? Conjugate base differ from the acid by having one less hydrogen plus. Okay? So let's look at this reaction. Okay? So this is nothing but acetic acid. This is your vinegar. All right? And it's water. So this is primarily the acid. Yes or no? This is the acid. If this is the acid, what is that? That is the base. So if you look at Bronsted-Lowry theory, what does the acid donate? The acid gives the hydrogen plus to the base. Yes or no? So the acid has now become what? Acid has become this. Is that what is left of the acid? Do you agree? This is the base, and what is left of the base? This is what is left of the base. Is that right? Now, if you consider this forward direction, this is the acid, this is the base, right? If the reaction goes in the reverse direction, which is now acting as the acid? Is this going to act as the acid now? And is this going to act as the base now? Is that the direction of the proton transfer for the reverse reaction? Yes or no? Therefore, this is now called the conjugate acid. What is this? This is the conjugate acid. And what is that called? The conjugate base. Yes or no? By definition, the one that accepts is the base, that one that gives us the acid. But if you look at the base and the conjugate acid, what do they differ by? By a hydrogen plus. The acid has one more. If you look at the acid and the conjugate base, what do they differ by? A hydrogen plus. The base has one less. So here is an acid. What will be its conjugate base? F minus. Do you agree? Is it one less? Hydrogen plus. So H3PO4. What will be the conjugate base? H2PO4. But now that you have removed the hydrogen plus, what is left? It now becomes negative. H2PO4 minus. What will HO3 plus become? H2O. Okay? That is the conjugate base. This is F minus, if you can't read it properly. Alright, let's move on to the next side. So now we want the conjugate acid. So what do acids have? One more hydrogen. Is that right? So what will be the conjugate acid for this base? HBr. By the way, ignore this negative sign. That is not correct. H2SO4 is a neutral compound. Alright? But no, we'll not take this to be the base. Cancel this out and write it as HSO4 minus. If it is HSO4 minus is the base, what is the conjugate acid for that base? It's H2SO4. If CO3 minus 2 is the base, what is the conjugate acid? H, you're adding one more hydrogen, CO3, because you added a hydrogen plus, what will the charge now become? Just -1. Are we good? Do we understand conjugate acids and bases? All right. Yeah. The immediate conjugate acid only differs by 1. H2CO3 is not its conjugate acid. Okay, it's not. If you go into AP chemistry, those are one of the questions they'll ask you. They'll give you H2CO3 as one of the choices. They only differ by 1. Okay? Now, in terms of a pH scale, all right, what is pH? Let's define what is pH. pH is defined as negative log of hydrogen ion concentration. Yeah. All right? What is, if it's 10 to the 2, what is log of 10 to the 2? 2. So if I take log of 10 to the 2, it is 2. If I take, what is the log of 10 to the -2? What is the log of 10 to the -2? -2. But if I take negative log of 10 to the -2, what is it? 2. And that's what is pH. It's negative log of the hydrogen ion concentration. Alright? Guys, way back, Rajiv and what are you doing? Burke. Are you still working in a math homework?
La clase de ciencias sociales. No, no, no,
Every single class.
un proyecto.
Every single class.
You should burn it.
I should burn it? Good suggestion.
All
All right.
Put it on the recording.
It's getting recorded. All right. Now, the pH scale was invented for the wine industry, actually. Way back when wine was discovered and it was acidic, people wanted to know how acidic it was. So the real number, the real concentration of the hydrogen ions would be something like 10 to the negative 2 or 10 to the negative 3, and people would be like, huh, what are you talking about? So for a layman, these are mathematical terms that they didn't understand. So Sorensen was the scientist who decided to say, you know what? People don't understand if you say 10 to the negative 2, 3 and all these things. Let's make it a whole number. All right? And he defined a pH scale and he said it's negative log of the hydrogen ion concentration. Now when people came to the shop, the acidity would be 2, 3 and people were like, yeah, now I get it. It would be a whole number. Does that make sense? And so was invented the pH scale. Now, and we've used it ever since. Okay? Acidic is when pH is less than 7. Base is when pH is more than 7. Neutral is when pH equals to 7. Please remember pH scale is defined with respect to water. When substances are dissolved in water, what is their hydrogen concentration? Does that make sense? Yes.
So, neutral, it was like 6.95.
That would be acidic.
But if you rounded it to like 6,
it's very, very slightly acidic. That's why you say less than and more than. All right. So those are mathematical terms, and that's how it is, and that's how we classify them. All right.
and it said slightly acidic or neutral when you did
You would say it's slightly acidic. 6.9 is slightly acidic. It's not 7. It's not neutral.
But would you, so you wouldn't apply this when you do that?
Okay, sig figs I'll teach you when I actually start calculating. I'll do that a little bit. All right. Now, let's look at the hydrogen ion concentration again. This is 10 to the negative 5. Is this a whole number? 10 to the 5 times 1 is nothing but 10 to the negative 5. Yes or no? And pH scale by definition is negative log of. So if it's raised to negative 5, what is pH? 5. If it's negative 11, what is pH? 11. All right? If the pH is a whole number, what is your hydrogen ion concentration? 10 to the negative 7. If the pH is 13, what is the hydrogen ion concentration? 10 to the negative 13. What do the two add up to? pH plus pOH always adds up to a 14. All right? So, if the pH is 4, the pOH is 10, and what is my hydroxyl ion concentration? 10 to the negative 10. If the pH is 2, pOH is 12, and it's 10 to the negative 12. This is a 3, and that's a 10 to the negative 3. Now, what are indicators? Are substances that indicate if a solution is an acid or base by its color. So we have to know phenolphthalein is colorless in an acid and is pink in a base. Litmus is red in an acid and blue in a base. Now, this is real easy to understand, but unfortunately, most real life substances are not that simple in their concentration. All right? Are not that simple in their concentration. Oh, you have this as the next one. Okay, let's. So you guys, you need to practice this page.
Yeah.
Okay, so this is a real easy worksheet. Now please remember, you're learning that pH plus pOH equals 14. Is that right? Now, always remember to determine if a given substance is an acid or a base based on your pH scale, and do not get confused with the pOH scale. So let's do an example. All right? So the pOH is given to be 10 to the negative 5. I mean, the hydroxyl ion concentration is 10 to the negative 5. What is your pOH? 5. So therefore, what is your pH? So what is the substance? Is it an acid or a base? It is a base, and your hydrogen ion concentration is 10 to the negative 9. Yes or no? I think you can complete this worksheet, and please understand it as you're doing it. Let's go back to this worksheet. Okay? This is the next one, I think. Right? It's the next page. Okay. Now, so this is how we learn how to calculate molarity of solutions. And when you add a certain amount of the substance, this is how you get your concentration. Yes or no? For any given solution. Right? So, if you have to express or find its pH, all you do is, I'm rewriting this big so that I can show you how I'm moving the decimal. It's two places. I can rewrite this in scientific notation as 10 to the negative 2. Yes or no? Is this given substance an acid? Therefore, this concentration is the concentration of my hydrogen ions in solution. Does it make sense? When this substance is dropped in water, it will produce hydrogen ions. If that is the concentration of my hydrogen ions, my pH equals 2. If because pH is the power. Yes or no? Is pH the power? Is it the negative log of? Did we just do that, Luke? Alright? So the next substance is, what is it? It is a base. Guys, it looks very easy on the surface. If you are not putting your head to it and trying to understand it, it will look very easy, but when you actually take a test or a quiz, you will get things wrong because there is no depth in understanding. Oh, she's adding, she's subtracting, she's raising it to the power, but no understanding is happening here. Okay? This is a base. When you drop a base in water, will it release hydrogen or hydroxyl ions? It will release hydroxyl ions. The hydroxyl ion concentration is what? If I express concentration like that, what is it? 10 to the negative 3. Therefore, if I know my hydroxyl ion concentration, do I know my pOH or my pH? My pOH is 3. What is my pH then? pH is 11. And the question may ask you to solve for pH. If you don't pay attention to the details of the question, you will get it wrong. Now, this is, if I could express it as 10 to the negative something, it's very easy for me to find the pH. It is just the power. Yes or no? If it is not a simple power, but if it is a number like 2.5 molar, all right, you need your calculator. Please pull out your scientific calculator. So, this substance is a base. Please get a scientific one that has a log function in it. All right? This is a base. The hydroxylane concentration is 2.5 molar. What is pOH by definition? pOH is negative log of my hydroxylane concentration. Yes or no? In your calculator, find the negative sign, not the minus, but the negative, which is way in the bottom. Hit the log button. Hit the log button and punch in the number 2.5. And hit enter. What do you get? Negative 0.3979. Alright? Now this is only two numbers, so I'm going to round it to 0.40. Alright? 0.40. My pOH is a negative number, therefore what is my pH? pH equals 14 minus of minus 0.40. Therefore, my pH is 14.40. Right? Okay. Now the confusing part is the pH is more than 14. Can pH be more than 14? Yes. Alright, remember the pH scale is defined with respect to water. Alright, waters, we will, you kids don't need to know this concept in depth, but remember, water, when it self-ionizes, alright, water plus water gives H3O plus OH minus. Alright? It itself gives the hydrogen and the hydroxyl ions. And if you look at a neutral water concentration, the hydronium ion concentration is 10 to the negative 7. And therefore, 7 is defined to be neutral, and the scale is based off on 0 to 14. Okay? Because substances are dissolved in water, and water is used as a solvent to define the pH scale. There are substances that will produce more hydroxyl ions or less because they completely ionize. As a result of which, the pH scale can be more than 14 or less than 14. If the given concentration is 1 molar, the pH will be 0. But if the concentration is more than 1 molar for an acid, the pH is going to be negative. So let's look at this substance. Is it an acid or a base? It is an acid. So I can directly find out what is the negative log of this concentration. What is the negative log of this concentration? What is it? How do you find it? It's 1.43. All right? Now, I'm not going to pay too much attention to sig fig when it comes to log functions. All right? But let me tell you something. All right? When I have 10 Let me do
Yoga.
10 to the negative 3.
You?
Say 10 to the negative, Burke.
There is no shot.
I don't want side conversations when I'm talking, please. Alright? So when hydrogen ion concentration is 10 to the negative 3, and you write pH equals 3, it's actually the power. Yes or no? And the power is what gets translated as this. Right? So the first number in pH is not said to be significant. If you write a number as 2.5 times 10 to the negative 3, do you ever take the negative 3 into consideration when you talk about sig figs? No. You only look at these two numbers. Yes or no? So when you take pH, the very first number is never accounted for in sig figs. So this concentration should technically be expressed as, if it had been expressed as 1.0 times 10 to the negative 3, do you understand? This is how many sig figs? 2 sig figs. So when I write this, how many sig figs must I report my answer to? 2. Alright? So if I look at my concentration here, if you do this example, alright, that has a concentration of 2 sig figs, but if I give you a number like 2.3 times 10 to the negative 3 and ask you to find its pH, what is the pH? Find the pH.
Negative.
It's not negative 3. You'll get a 0 if you do that. How do you find the pH? Put the number in your calculator. Do negative log of this number. What do you get? Negative log of, did you do it all, Olivia? 2.638. Alright? Does this count? So I'm trying to calculate my pH here. Does this count for sig fig?
Yes. No. No. Just take them. No, you don't count it.
Why? Because that is the power that's been translated to 2. Yes or no? So how many sig figs is this? 2. How many sig figs must my answer be reported to? 2. So what is my pH? 2.64 is my pH to correct number of significant figures. So even if you're going, let's do the reverse. Alright? So did I put that paper out or not? I don't think I did. Okay? So let's distribute this paper. 1, 2, 4. Distribute it. Alright, please pass it down to all the students. Alright, Luke, pass this down, let each student have one of this worksheet. So guys, in the previous years, okay, Rajiv, can you please get up and come and sit here right next to Lauren, please? Thank you.
You join this.
Thank you.
You learn like this much more.
Okay? Alright, so in the past years, I have not given explicit notes. I've had students practice with me and that's all I've done. This year I typed up this worksheet. It just tells you if the concentration is not a whole number, how do you determine the pH? Did we just do this example?
Good morning. Teachers, please pardon the interruption. We begin our morning Teachers, television, and special
It's my daughter's birthday too.
Stop by room A.